Using the distributive property for multiplying expressions. So hopefully you remember the distributive property from earlier lessons, but this is 4 times 3 plus 2. 3 plus 2 is in parentheses, so we do that first. 3 plus 2 is 5. 4 times 5 is 20. But the distributive property says, well, I can bust these apart and multiply 4 times each of these individually, just keeping the addition or subtraction between them the same. So 4 times 3 is the first term, plus in the middle, and then 4 times 2. In other words, 4 times 3 is 12. Move this up out of the way here a little bit. 4 times 3 is 12, plus 4 times 2, which is 8. Yep, still 20. Math is consistent. As long as you're following the rules of math, whether you do it one way or another way, you should get the same answer. If that weren't true, Earth would fall out of orbit and plunge into the sun. So be glad that math is consistent. Now we're going to try this with a variable, and the exact same thing is going to happen. We're going to take this 3 times, remember, no operation sign between the number and the parentheses, just means multiplication. So we're going to say 3 times the first term. You see now why we don't use the x symbol for multiplication in algebra. That gets confusing since there's already an x. The second term here is a 2. 3 times 2. Well, the way we write 3 times x in algebra is just 3x. Once again, we don't need the times sign. 3 times 2 is 6. So 3 times x plus 2 in parentheses is going to equal 3x plus 6. One more quick example just like this to emphasize the point. 5 times, what's in parentheses, y plus 2. You're probably not going to have to write down this part. That's supposed to be a 5, by the way, but sometimes the pen doesn't start writing till halfway through and it comes out looking weird. So again, each term here has a 5 attached to it now. Well, 5 times y, we just write, I keep trying to write with that pointer, as 5y. 5 times 2 is 10. Okay, I can imagine I hear you saying, well, what happens if there's a coefficient inside the parentheses? Remember, the coefficient's just the number in front of the variable that means, well, in this case, the number is a 3, so 3 times x. Well, I imagine you asking that question because it's kind of lonely making these videos. I have to be in a quiet place, and so I'm imagining you asking me questions. So how do we do this? Exactly the same way. Now you'll get good enough at this that you're not even going to have to write these things down. You'll just kind of do this part in your head. But just to emphasize what we're doing, 4 times 3x, hopefully in the previous video where we talked about multiplying terms, you know that 4 times 3 is 12, so 4 times 3x is just 12x. And 4 times 6 is 24. Neither one of these is the correct form that you have to use. It's not like fractions where if you get the answer 2/4, you have to simplify it to 1/2. Sometimes this is more helpful. Sometimes this format's more helpful. It just depends on what math you're doing at the time. All right, next up, just a few examples. All right, here is a very similar example, except there is a negative number on the outside. Now, if you're not comfortable with multiplying and adding and subtracting integers, this can get a little complicated. You might want to go and review that, but you're not scared, are you? Don't actually answer that out loud, because if you're in a room full of people, they're going to think you're odd. Okay, so here we go. Negative 3 times 8x. Well, 3 times 8 is 24. Let's just get that part out of the way. And of course there's an x. And the only real question here is, what is the sign? Well, we're multiplying a negative times a positive. Hopefully you know that that means it is a negative. Now what about this second bit? This is minus 6. Now subtracting 6 is really the same thing as adding negative 6. Subtracting is really the same thing as adding the opposite. So subtracting 6 is, we're subtracting a positive 6 here. And we can think of that also as simply adding negative 6. Why am I saying all of that? It's a little confusing at first, but basically what you need to do is think of the operator here. This is a minus sign. Just whatever that is, plus or minus, think of it as the sign of the second number. So for example, negative 3 times negative 6 is positive 18. And then we're going to do the same thing kind of in reverse. I'm going to take the fact that it's a positive 18 and just make it plus 18. I'm treating this plus kind of as the sign of this 18 and also as the operation here. You'll see a few more examples that should make that clear. It's the one thing that people find a little tricky doing this. All right, another example. We've got a negative number on the outside being multiplied times all these things in the parentheses. And again, you don't have to draw these arrows. And at this point, I hope you will just sort of get comfortable with the fact that it was 8x minus 2, but we're just going to think of all of these terms in here as being added. And the minus sign is going to mean that we've added a negative 2. So we're just going to do negative 4 times 8x. Negative 4 times 8 is negative 32. And of course, that x is still there. Negative 4 times negative 2. A negative times a negative is a positive. All right, what's going on with this one? There's a negative sign here. There's no number here. Well, that's okay. In fact, one way you could think of this is simply as if there were a negative 1. So we've had, what, negative 3, negative 4? I don't remember, but in any event, just treat it like a negative 1. And then you could multiply it out, just remembering the basic rules of integers. Negative times a positive is negative. So this would become a negative 5x. And a negative times a negative is a positive. And that's the correct answer. Now there's an even quicker way. Once you get used to this, you're not gonna change it to this. And I just want to apologize. There was a cat outside the window meowing. So I chased the cat away, and we'll continue here. So what I was saying, it's a shortcut if it makes sense to you. And basically it's just this. A negative outside the parentheses, all it does is it changes the sign of everything in the parentheses. It's just like flipping a light switch. So if it's on, it'll go off. If it's off, it'll go on. If it's positive, it'll go to negative. If it's negative, it'll go to positive. So you would just quickly go through and apply the light switch to each one. This 5 in front of the x does not have a sign in front of it. We know that means it's negative. No, it means it's positive. It's going to become negative. And then here, this says minus 2. But our light switch, the negative sign in front, is going to switch it to plus 2. So whichever way you think about it, multiplying times negative 1 all the way through, and even if there were more than 2 terms in here, this would work, or whether you just want to get good enough at this to see that negative sign in front and just swap the sign of everything to its opposite. Either way is going to get you there.